Okay, let me just discuss with you one problem which we were not able to finish a while ago. Problem number 6. Test scores in biostatistics are normally distributed with a population standard deviation of 6.3 and a random sample of 50 scores, and the exam has a mean of 41. Estimate a 95% confidence interval for the population mean, and letter B, 90% confidence interval for the population mean. So let's identify the given in the problem. What are given in the problem? Okay, the problem gives us the mean. Okay, the mean is 41. Okay, the mean is 41. So let's write down 41. The population standard deviation is 6.3. Okay, so sigma is 6.3. N is 50. And letter A asks for 95% confidence interval, whereas letter B asks for 90% confidence interval. Okay. So let's solve together. Solution. Okay, once again, x bar plus minus for letter A. Since the confidence level is 95%, we are to use 1.96 times the S times E, times SE, or the standard error. X bar is 41 plus minus 1.96 times, okay, in this case, the standard error is not given. Note, SE is equal to, okay, S over the square root of N. Okay, S over the square root of N. So here the standard deviation is 6.3 over the square root of 50. Okay, let's simplify. 41 plus minus 6.3 divided by 50, square root of 50 rather, 6.3 divided by the square root of 50 is 0.89 times 1.96 is 1.75 or 1.746. So this now will give us the two, okay, limits. 41 plus 1.746 is equal to, plus 41 is 42.746, whereas the lower limit will be, okay, 41 minus 1.746, which is 41 minus 1.746 is 39.254. Okay, so this is for letter A. So for letter A, we have the confidence interval 39. So answer is 39.25 to 42.75. So we are 95% confident that the population mean lies within 39.25 to 42.75. Now we proceed to letter B. Okay, for letter B, 90% confidence interval. Okay, what about for 90%? Z here, Z value that we made use of is 1.96. So from table lookup, for 90%, then if we draw once again our normal curve, these are the tails. So alpha, or the significance level, is 1, okay? 1 minus 0.9 from 90 divided by 2. So alpha is equal to 0.1, okay? 0.1 over 2, which is 0.05. So the tails, the area under the tail, okay, this area is 0.05. And in like manner, this is 0.05 also. Now, should I use the other table? There's another table which gives the areas from the z value to 0, from that z value to 0. So if this area is 0.05, and this is exactly half of the normal distribution, then half of it, the whole of this, okay, has an area of 0.5. Okay? So the whole of this, let me just highlight, including this, has an area of 0.5. Okay? The area is 0.5, half of the normal distribution. But since we would like to find out the area from here to 0, then we subtract this small portion here, the area of the small portion, or the tail, area under the tail, which is, okay, so minus 0.05, and that is 0.5 minus 0.05 is 0.45. Okay, so 0.45. By table lookup, we will identify that z value, okay, z value corresponding to 0.45. Okay, the area from that z value from 0, or from the middle, from 0 to that z value, 0. From 0 to this z value, the area is 0.45. From another table for z. Okay, so let me show you one more table. The table that we have made use of a while ago gives the area to the left. So from that z score to the left until the other tail. This particular problem, it's from z to 0. So the difference is, so look at the table. Entries in the table give the area under the curve between the mean and the z standard deviation above the mean. So from the mean, the center, from 0 to that z score. What are we looking for? 0.45. So where is 0.45 found? 0.45 is in between 0.4495 and 0.4505. So it's in between, which means that our z-score would correspond to, look, 1.645. If we get the sum, 0.4495 plus 0.4505, 0.4495 plus 0.4505 divided by 2 is exactly equal to 0.45. So 0.05 plus 0.04 divided by 2 is 0.045. So it's 1 point, so it must be 1.645. So it's 1.645. That's the z value. So let's go back. So by table lookup, the z-score is 1.645. This is why if the confidence level is 90%, we multiply SE, or the standard error, by 1.645. We proceed to letter B. Asks us to calculate 90% confidence interval for the population mean. The sample mean x bar is 41. Okay. What else? Our standard deviation is 6.3 and our n is 50. So we are ready to compute for the lower and the upper limit. So S is 6.3 and n is equal to 50. So, x bar plus minus 1.645 times SE, which is standard deviation 6.3 over the square root of 50. And then just simplify. Okay, okay, let me just, to be consistent, we did not yet evaluate here. So let me just write first 1.645 times S. Is it S? I think it's sigma. So let's use the proper symbol over the square root of x bar 41 plus minus a 1.645 times 6.3 over the square root of 50. Okay, let's simplify further. 41 plus minus 6.3 divided by the square root of 50 times 1.645 is 1.466. Okay, which means that our limits will be 41 minus 1.466, okay, minus is 39.53, and 41 plus will be 41 plus 1.466 is 42.466. Okay, so finally, our answer is from 39.53 to 42.466. Okay, and that's it. So in our previous answer, 39.25 to 42.75, and for letter B, 39.53 and 42.466. Okay, so take note that this has a narrower, letter A has a narrower interval. This is a narrower interval compared to letter B. Okay? So this is narrower compared to letter B. The narrower, the more precise. Okay? The more precise, or the higher the precision. Now, we can use Excel also to solve for the confidence interval. Let me show you how to make use of Excel. So, let's identify all the given. Our mean in the problem is 41. Our standard deviation, SD, is 6.3. And N, the number of observations, is 50. Confidence, just type in confidence and you'll find this. The last one, choose the last one, confidence, and then it will require alpha. Alpha is 1 minus 95%. So once more, equal sign, and then type in confidence. Choose this. Choose this one, confidence, the last option, confidence. Choose that. Your alpha, once more, alpha is 1 minus, okay, 1 minus the confidence level. So 1 minus 95% is 5%. Converted into decimal is 0.05. Next, that is required is the standard deviation, which is 6.3. And then comma, size is N, number of observations is 50. And close it in a pair of parentheses, and that's it. Compare it to, okay, let's go back to our PowerPoint presentation, or to our, okay, going back to letter A, it's in fact 1.7, did you see this? 1.746. Okay, 1.746 is the result of the Excel calculation. Yes, 1.746. This is the product of Z and the standard error. Okay, so let's go back to our Excel sheet. There it is, 1.746. So, okay, so lower limit is equal to 41 minus this. Okay, enter. And your upper limit will be mean, okay, sample mean which is B1, plus this. Enter. Okay. Compare it to our answer a while ago. 39.254, round it up, and 42 points. So let's compare. Okay, so see this? 39.254 and 42.746. Now, let's show also the solution to letter B. So, for letter B, let me copy. Okay, so letter B. This is letter A. So, for letter B, 90% confidence, yes? Equals, type in confidence, the last option, and then it requires the alpha. So, your alpha is equal to 1 minus, okay, 1 minus the confidence level. And that is your significance level expressed in decimal. Alpha equals 1 minus confidence level. Okay, so this is your alpha. So for problem number 1, alpha here, alpha is equal to 0.05. So for letter A, let's compute for the confidence, but this we have to take note that alpha is equal to 1 minus 0.9, which is equal to 0.1. Okay, that's alpha. So, equals confidence. Okay, confidence. So, that one requires alpha. Alpha is equal to 0.1, comma, standard deviation is 6.3, comma, and the size is 50. And close it in a pair of parentheses. Okay, let's compare to what we obtained in letter B in our solution a while ago. Let's use this, let's see this, 1.4, okay, 1.4, there, 1.466, 1.466, okay, that's it. So let's go back to our Excel sheet. So now we are ready to solve for the upper limit and lower limit and upper limit. So lower limit equals 41 plus this is plus, and the upper limit, sorry, that is supposed to be minus because that's the lower limit. Okay, so the lower limit should be minus. Okay, and the upper limit should be equals mean plus the product of z and the standard error. Okay, so 39.53 and 42.46. Okay, 42.46. So let's see, check from our previous solution. Okay, that's it. So there we obtain the same value, 39.53 and 42.466. Okay, so I was able to show you two steps or two solutions, two ways by which we can establish the confidence interval. So you can use Excel or you can do it manually. So looking back at our Excel answer, so this is for 95%. So the interval is 39.25 to 42.75. So this is our 95% C confidence interval, whereas for 90% it's 39.53 43 to 42.47. Okay, class, this is the confidence interval at 90%. 90% CI. CI for confidence interval.